Hello and welcome back to our Excel examples. I wanted to give you a more complex example of using formulas and a really good way to set up those formulas when they are complex. What we have here is an example of some equation. It's a rather complex equation, and in this equation it's a dampening type equation. It has some oscillation in it, and we see over time that it goes out and oscillates towards some value just between 0 and 1 in millimeters. So this is the time that it all occurs and happens as it goes up and down. What we have here is we're saying that y equals this 3x plus cosine omega t. So omega is some constant, and I've defined it as 0.01. Typically it's in hertz or per second, and this is per t time, which is in seconds, so it's unitless. That's what we want for radians, and also minus sine t, and this t also we can say it's in time omega of 1 second per 1 hertz per or time per second. Excuse me. And in the denominator we just have the square root of 4 plus 5t. Okay, and we want to solve for y in our equation. I have set up the table on how we're going to look at this. We have our value of x, and it's set at 3. It's some constant value that we have, and so is omega. So what we want to do is set up our table, and we want to look at, our table from time 0 in half a second increments up to, let's just say up to 50 seconds. And this is really easy to do. Again, we can highlight these two, and you will see as I drag it down, it will increment all the way up to whatever value I want. I'm going to go up to 50. There we go. And we'll automatically fill it in. I'm going to make it look a little nicer. I'm going to have this have a decimal place of just 1. So there it looks nice, and we will also center it all. There. The best way to solve these types of problems, so this gives me my range of values for t down that first column. And the best way to look at this is to kind of break this up into its components. So one thing I've solved for is omega t. You will see that's this wt or omega t, and then I'm solving for cosine of t. And then I can calculate my numerator. My numerator is just going to be this equation up here. Ooh, the upper part, right, the numerator. So let's just set this up. So here we have equals omega, which is this, and I'm going to make it absolute, right, times my time, and we know that that should be 0, right? And if I kind of go down, I can double click that handle. If you didn't see that, you see I move my cursor over it, double click it, it will go all the way down for me, right? And we see at 50 it's 0.5, which makes sense, and we can kind of check. It's good to just check to make sure things seem to be right. We see 1 times 0.01 is 0.01, so that all seems to be working out very well for us. Now we can use, and we can also check to make sure that it's always grabbing my 0.01, right? So now let's look at writing our cosine function. Here we have cosine omega t, so it's omega t, which is this value here. And notice I didn't make it absolute, I just made it relative, because I'm always going to be taking that value. And the cosine of 0 is 1, right? So it's always 1. So if I click that down, you will see that it changes as it goes down. Okay. So now we can calculate our numerator. Our numerator equals 3 times, and I'm going to make this absolute because it's a constant, plus our cosine, and I'm going to leave that as relative because I'm going to copy it down as it changes with time, plus, minus sine of t, and that also will be relative because I'm going to see that value is 10. Let's see if that makes sense. We know 3 times 3 is 9, plus 1 is 10, and the sign of 0 is 0. So 10 does make sense. Let's copy that down. And now let's do our denominator. This is the square root function. And we have 4 plus our value of 5 times t. We're going to leave that relative. And we see that that should equal 2, which it does, because 5 times 0 is 0, and then 4, the square root of 4 is 2. So 5 divided by 2, this should be 5, right? So we have equals the numerator divided by the denominator, right? And we see that we have our equation. So that seems to work out fine. We can highlight both of these and actually double click and have them go down. Oops, excuse me. I have this problem with this function that I created here. Let's see if this will do it better. There we go, and I can bring this back in. So see, it's going down to this 0.63. And that seems to be what we're seeing here. It's still oscillating some. So that's a way of creating these tables. Now, yes, I could have probably created it and used this all in one box, right? But what's nice about splitting out your formula is you can easily check your formula as you go along to make sure you haven't made any silly mistakes. So I would highly recommend breaking out your formulas when they get complex into smaller parts and then combining them like we did here. Y is just the numerator divided by the denominator. I hope this is helpful for you. If you do have questions, please always ask me and I'd be more than happy to help you. Have a great day.